All right, everyone, welcome to meeting 48. We've got two demos. We've got a couple of talks on decentralized identity. Will probably be the main one. I have a little bit of an update on some proofs for a new type of CRDT and OT. James is going to show a demo of Metaverse. Greg's going to show some antimatter demo. And let's start with our check-ins. Just repeating things that Seth already said. What's everyone up to? How are things going now that we're recorded? Yeah, Jay.
Well, Randy Graham is on the session this evening, and Randy and I, let's see, can you hear me okay?
Yeah, I hear you great. Hey, Randy.
So Randy and I just wrapped up a boot camp for the Stellar Network. We created a project. We're part of a team that created a project called SNAC, which was Stellar NFT, NFC Access Control. And we're combining the Internet of Things with the Stellar Network for a very simple way to interact with the Stellar Network. And it's pretty intense. And so now the community is voting on the projects. There were 152 applications, 50 projects picked out of the 152, and 47 presented. So we're one of the 47.
Congratulations.
So, yeah.
Is it a competition for funding or for getting approved as a part of Stellar Protocol or something?
It's basically for funding. We just applied for $7,500 in funding, and I think they've got $400,000 or $500,000 to distribute. And there's Chad; he's also on a different team. But the interesting thing that the group might be interested in knowing is that the Stellar Network is incorporating native smart contracts into their network, and they have, I believe, $1 million to distribute between now and December 15th for hacking on the Soroban smart contract. And then behind that, I believe they've got $100 million to foster the introduction and adoption of the Soroban smart contract protocol. So if anybody's interested in that, I'd be happy to elaborate. So
That's cool, man. It's big bounties. Yeah.
I can go next. So I've been working on I'm sorry, messages. I've been working on getting diamond types working with so I've rewritten all of the OTs. Sorry, my brain's all over the place at the moment. I've rewritten all the CRDT code and diamond types again for for the JSON structure stuff, following the way that I structured it in JavaScript, which I kind of like more. And I've been working to integrate the text editing with all of that, which right now involves like taking the whole merge algorithm and making it work even if some of the operations aren't text edits or aren't edits on this particular item. So the vague plans, well, yeah, I can go into it in a lot more detail, but yeah, having like one causal graph for the entire thing, and then having different items which like have their own histories. So yeah, it's been keeping me busy.
Cool, man. Yeah, that sounds really useful.
Yeah. So yeah, the goals to getting the thing that I demoed a couple weeks ago, working from Rust and working with text as well, using all the CRDT code.
Nice.
So, yeah.
I have been working on a few things. One of them is I've started up a GitHub repo of introduction to CRDT tutorials, and I've started with eventual consistency. And I've been working on the Metaverse in a Box project, which I'll be showing a bit later. And through that, I've been like fleshing out the sync engine. And one of the places that I have been particularly interested in recently is using things similar to what Valve did with their source engine, where you can like intentionally insert actions back in time. Like if someone shot someone, you want to be able to make sure that like the person who like it's essentially like allowing you to do things that I think a lot of the CIDT work that we've been doing so far like hasn't supported for like specifically resolving conflicts in like generally they're things that are occurring while you're both online. So like if two people are interacting, like and how do you decide on like who shot someone or if someone moved out of the way, etc. So yeah. Anyway.
Is it just me, or are we all a bit inarticulate today? There's something.
Sorry.
No, I'm just the same.
Feels like a slightly slow day,
Yeah.
which
I don't think it's just you, to answer your question. I'll I can go, I guess. I don't have much to report on Braid specifically, but I have been working on antimatter. I had some demo to show last time. That last time was a pretty packed meeting full of other great things. But beyond some graphics for this antimatter thing, we've been trying to change around how the we want to add a way to allow even right now the thing that checks whether who knows what is tied in with the sending of new updates, and we want to decouple those so that the system can, if it wants, to say ask the question, can we prune stuff without sending a new update? And that code is in there now, and I'd like the demo thing to be using it, but there's some bug in it at the moment. That's the status. I'll show that after these updates.
okay, I'll go. So two things that I can think of. Well, maybe, yeah, three things I guess I'll mention. So first thing is mostly what I've been doing is making progress on the mathematical proofs for this new type of CRDT and OT generalized thing that and working with RAF, I feel like we're making progress. It's like interesting actually getting into the mathematical formalism of what is a CRDT and what is operational transform, and then showing how they relate through this new approach, this time travel approach. And so I'm going to show some of that later today. And then another thing is I went to an academic workshop this last weekend was it basically a bunch of academics trying to figure out how to recreate science of like the publishing and thinking together on the decentralized web. And I don't think the decentralized web was not like everyone's core focus, but it was a core focus of a subset. And a whole bunch of them are like using Mastodon now as they've migrated off of Twitter. And then since Mastodon's open source, they're like hacking into it different JSON LD data types for like a publication and trying to get a lot of it. So it was like a bunch of decentralized web users I was like swimming with, watching them use different technologies. And I can see places that Braid fits in. And maybe I'll actually add that to the discussion at the end. There's like two big problems that they kept running into. And so I'll try to see if I can make time for that. And then the last thing is one of those problems. So I'll talk about that all later.
I'll just chime in and say that no major updates, still just trying to catch up. Probably just be a fly on the wall for the next few weeks, I suspect.
Cool. And I guess Randy, I guess your update's the same, your status is the same as Jay's. Chad, do you want to say anything, or you guys good?
Yeah, I'm good. I'm good.
Okay. Then we can jump into demos. So James and Greg, you guys are at bat.
Greg, you can go first.
Sorry, I said all right, but I didn't have my microphone on. Let me share my screen. Can people see my screen? All right, great. So this is this antimatter demo. I feel like people have seen this before. The thing that's new is, I don't know if you could see it right there. I'm gonna turn everything down here. There's a new animation regarding fissures. If we isolate somebody by chopping off their connections, so now they're floating over here, and they have these what I'm calling fissures. These things here, that there's a dot and there's this line sticking out of the dot. That line was one of the connections, and this is one side of it here, and the other side of it is over here, and it's pointing the other way. If you remember the animation, we can make another one happen right here, and you can, there's this new pink connection. Anyway, when the two sides of that connection come back together, before they would merely just disappear from view, but now I'm going to connect it. It won't go in slow motion, even though the messages are going slowly, so you have to watch it. You can load it yourself. It may be the animation may be better there. I'm not sure how Zoom will handle it. But all right, let's let the messages go over here. So he's saying, "Hey, tell me your stuff," or "Here's the stuff." And now, I don't know, do people see that? If they already have the information, that doesn't do another animation. Anyway, that is new. Another thing that's new is that when you hover over these guys, it adjusts. Like, first of all, it highlights just what you're seeing. And if there was complicated stuff, which we can make the system create some more complicated, well, goodness, down here. Let's just make it edit a lot. Okay, there we go. Then when I highlight something, it kind of highlights the parents above it, so you can see what's going into it, and it highlights it in this other diagram. These diagrams are the same. They're very similar diagrams. They're not exactly the same. And also down at the bottom, it's showing what the situation looked like at that time. And there's another of these diagrams, and in a similar way, it shows what part of that space DAG is being used by that part of the time DAG. Anyway, the thing that I'm working on now is, let's say that everyone, we'll disconnect these people here. We're going to let everyone talk to each other so they can try to prune everything away. They can't prune it all away because there's this fissure that's preventing them from, you can see in the time DAG here that some of these versions have the purple thing on them. And so it can't prune them away until it reconnects with this person. Now I'm going to reconnect with that person. However, it's still not going to prune everything away. So we reconnect, let the network go. And now it has learned about the fissure, all the explosions happened. These versions are not trapped in the fissure anymore, but the system at the moment doesn't have any signal to tell it, like it couldn't print it before, now it's reconnected with this person. And currently, if I were to type something, then everything will prune away because it had a signal to send the message to ask the question whether everything could be pruned away. But now, although it's not shown here because it was having a bug, there is a message you can send that will just ask the question without adding a new version. That is all. Any questions?
Yeah, this is really cool. I really like this. Seeing this in action with the little animations. I want something like this for diamond types, and for showing the causal graph diamond types, which obviously never prunes anything away, but at the same time, like you could see it grow. And I really like the idea of hovering the mouse over different spots and being able to see like the subset of the history that shows that. And it's interesting, the different things that you're doing with your mouse are actually mapped perfectly to a bunch of different functions I have in diamond types to do exactly the same kinds of operations. Like I've spent the last couple days writing a subgraph function to say like, hey, if this document is described by this subset of the operations, can you give me a subset of the causal graph, which is going to only contain the operations for that? But I really like being able to see it. The pruning awayness though, that's a quality of the peers though, right? Not the network as a whole. Is that right?
Yeah, each peer can prune away different stuff.
Yeah. So wouldn't it just be the peers that decide whether or not to prune something? Like you wouldn't need a network message?
It is the peers that decide. And each peer is like, they all look the same now, but in theory, if one of them actually had different data, it would show its different data on that peer. The issue right now is not the issue is that
message tells the peers that they can prune stuff away. It's still up to the peer to while still merging everything from all other peers. But it's
right
still
now,
up to the peer if it wants to prune.
In this demo specifically, the peers aren't pruning the stuff away at a moment that they could, and I want to tell them to do that. This update is not so much a change to the algorithm or what it could do. This is really an update to this particular network of peers. Is not smart in that they don't decide to send a message to prune everything away at a moment when they could, and I want them to be smart and send that message. But it was also the case that the code that I'd written that's called antimatter.js didn't have a mechanism in it, even though you could, if you knew what was going on algorithmically, you could achieve the same thing, but there wasn't a function in it that was that there is now called Marco, and it's kind of a pun on Marco Polo, but it's just going to ask the question like, hey everyone, are you all there? So that function now exists as well, just to make it easier.
But again, sorry, is that a network message or is that a message to the peers from this visualizer?
In my mind, those are the same. Maybe these green dots that are going from this peer, those are network messages going over.
Yeah, I'm just confused. Like if you got like if I was running this amongst actual computers, right? So like all the computers in my house are sharing a document. Yeah. Each of those peers could obviously decide that it, like just based on antimatter, that it could prune locally, right?
Yeah.
So it wouldn't. What's the point of having the network message then?
Wait, what's the point of having which network message?
A network message.
So Greg, I think there's a confusion here. Greg, you said the network message as the network message to tell them to prune. It's not a network message to tell them to prune. It's a network message that goes out and tells them to respond so that they all know that that they've all seen a certain point in time, which then lets them know that they can prune while still without receiving any messages that come from before that point in time. But nothing tells them that they have to prune. It just tells them that it's safe to prune.
Okay, I thought the antimatter algorithm already.
Mike is correct about that. Everyone's at this point here. Let's say at the bottom.
Seth, I'm pretty sure that Greg said that this wasn't a change to antimatter itself. This was a change to the visualization.
I mean,
it's a change to this. Sorry, I feel like
There's a new network message. I think that would be.
Let me try to resolve some confusion here. First of all, for Seth, your intuition is correct. The peers are sitting there, they're doing their own thing, and they can look at their time DAG and they can prune stuff based on their own decision to do that. Now, there is the antimatter gives them some advice about when is a good time, what can be pruned under what circumstances. the main thing that antimatter has is that the thing that I called this Marco message that Mike is saying exactly correct. It doesn't tell people to prune. It's an algorithm. Like, it's the core of the antimatter algorithm is this. It pings out, it gets these responses. If no fissures happen during that time, then the person who started the ping now has this magical knowledge that everything they knew about is also known about as well by everyone in their peer group. And that now they have this knowledge that they can use to collapse down different nodes in this time DAG, because they know that they appear as a set. Anybody who has them sees them all together or not at all. That's
Okay.
what this ping thing does.
Yeah,
Now,
I guess my understanding, maybe my understanding of antimatter was wrong, was that when those fissures happened, that both sides of the fissure, like when you send out this fissure message, that you'd specify the like last known version of the peer on the other side, so that everyone like like that you'd
that's
end up
exactly right.
tracking the versions.
So if we
Yeah.
do it right here, this is an example.
Yeah.
So this guy, if we do the fissure,
Uh-huh.
we kill this, then this node at the bottom, well, actually all the ones that are, a lot of them are going to be in this fissure. So we'll do it. I'll unpause it here. And a lot of them, like down from here, all these ones are in a fissure. The ones below are not, because those are more recent than that fissure.
Right.
But all these are trapped in a fissure. They have the little purple thing. And the other guy over here has anti-purple things on all of those similar nodes. And neither of these people is going to ever get rid of any of those versions until they see the other side of that fissure.
Yeah. I don't want to, we don't need to belabor this, but I guess I'm just confused why we need an additional network message, given that all of that information is already available to all of the peers.
So the original
All of which
network
information?
message,
The information about which points in time are trapped.
there's a different bit of information that's not visualized. And that is it's kind of visualized, and you see it a bit with these green things versus the darker green. There's a thing that happens, again, that isn't visualized, that happens when this ping goes out, like when somebody originally writes something and they send a message to everyone and they all respond with an acknowledgement, and the original person who wrote that message receives all those acknowledgements. Something happens right then that isn't shown in this visualization, except that unless you know what the messages are. I didn't explain it, but that's the thing. That unshown thing is the thing that right now only happens when you type a character. It initiates this sequence. But I want to make it, and it is the case now, that sequence can be initiated just at any time at all.
Okay, sorry, I didn't follow any of that. It's all right. I'm just gonna let this go.
Okay.
You said that it wasn't shown a lot of times, but you didn't say what it was, and I was holding on, waiting to hear what it was. But it's okay. Let's move on.
I did say the thing that. Let me just.
Sorry, I got lost.
I understand. Let me try one more time. All right. This I'm gonna reconnect these two guys together. So first of all, let me let all the network messages go through, unpause it here. I'm gonna connect these two people together. And we're gonna let the messages go through. And what I claim is that these versions are all gonna remain.
Yeah, I believe you.
I know.
And I'm confused why the nodes don't know that they can remove those edits.
Because there could be another fissure created. Just because you connected here, another fissure could be created somewhere else.
And you don't know about the fissure yet?
I think so, yeah.
The reason
you have to get an all clear. When everybody's reconnected, you have to do another 2-phase of act to know that everything's all clear before you can start pruning.
Great, that's very helpful. Thank you.
Like right now, the reason they can't prune, like the reason this guy can't prune, is because he still doesn't know about the other end of the fissure. The network messages are very slow, and it hasn't gotten there yet. When it gets there, so now it's gotten there. So your question is basically, why can't this person prune right now?
Yes.
And the reason that they can't prune right now is that the fissures aren't the message that lets you prune. The only thing that lets you prune is this other unseen message. It tells you that all of these are gathered together.
I can hear that you're asserting that. The point of confusion for me was why can't it prune, not can it prune. So I hear that it can't prune, but don't worry. What Mike said makes enough sense. I think we should move on in the interest of time.
Okay, well, the reason that it can't prune is that it doesn't know that those versions appear together. It needs.
I think Seth is saying that his
tell them that
question
they're-
was answered.
Yeah. Yeah.
Okay.
Let's pick it up at the end if we've got time, because I'd love to go into more
I
detail.
don't know.
on
It
this.
seems like you're saying that your question isn't answered, but you want to move on, which is fine. That was my confusion. If your question is answered, then we don't need to return to it.
Let's move on. We can return on that, but that's very cool, Greg. I really like it.
I want to make one comment on that too, if I can. Just do a little share thing. One thing that occurs to me while Seth, while hearing you talk about this, is that let's make some stuff here. Okay, when you're mousing around in here, we're seeing the space tag at the bottom show just the stuff from the top down, and I think that the algorithm that you've got kind of computes when you do a merge. It computes enough space tag from the bottom up in order to do the merge.
Are you asking me?
Yeah, with when the new version of diamond types.
Oh, yeah, it does the merge from the top down still.
Okay.
Yeah, it's when you're merging. If there's like, say, like a bubble, and then there's some stuff, and then another bubble down here, or like then we're merging down here. We don't need to recompute all the stuff up here. Like,
right.
You just have to. You can just do the merge from any point that you know to,
Yeah, so that's like that'd be the equivalent of having computing like the space tag from the bottom up instead of the top down. So all the stuff up here would be dark and the stuff down here would be lit up. So I'm thinking it might be interesting to have a visualization that shows the inverse here. That might be the way those things work, because there might be some isomorphism between the stuff.
There might. It is still top down though.
Well, I think what Mike means by bottom up is that, like, in that whole DAG, you're looking up for a point that you can then go downward from. But in principle, although I haven't found an algorithm for it. I said there was, but I haven't. You could go from the bottom up, like the information that you're constructing something that uses just the information at the bottom, you might say, of the whole time DAG. There's more of the time DAG above where you're doing your computation.
So that's not currently entirely true. Like if you had right now, if you had a snapshot of the most recent point in time and all of the history, you can't use that snapshot to be able to go back in time. I could write that code, but I have not written that code. Right now, you can take any snapshot and then you can go forwards, you can go downwards. So if you had a recent snapshot and some recent changes, you could go downwards from that recent snapshot, but you can't go back up again.
Oh, you actually go from a snapshot.
But the snapshot could be the start of time, and it often is, which is an empty string. So it's very easy.
I see. Do you sort of cache a snapshot that's more recent?
No, the code doesn't. So the idea is that, like, if you're at some version, you want to merge in some other version. So I'm at some branch and I want to merge in a different branch. Then I can use the snapshot at the version I'm at, and I can go downwards, which might involve some changes that were like earlier in time, that might have been earlier in clock time, but they're new changes for me. So I can go from this snapshot, which is my branch, to the merged branch by going downwards, and that's how the code's written. Does that make sense?
No.
I'm just gonna pin this and try to follow up with it later.
Okay.
I like the demo, Greg. I think the visualizations are really cool.
Thanks. I'm sorry it doesn't make sense. I feel bad.
As Seth said earlier, I think everyone's miscommunicating today.
It makes like 98% sense. It's just the last 2% that I was getting stuck on. But that's okay. Shall we move on? Do you want to do your demo, James?
Yes. Okay. So this is going to be the biggest stress test of my server that I've done yet. So if everything goes to shit, then you know, here's a link. If everyone wants to click on that, you can join my metaverse. And there's the screen is going to get cleared because I currently have a thing where, yeah, don't worry about it. Anyway, controls, W, A, S, and D move. You can move your mouse cursor to do presence information. 0 through to 9 allows you to edit the world. Pressing T allows you to go into 3D mode on space jumps. And there's also so you can jump on top of the tiles and you can go inside the lava and you can see other characters in the lava. There's also like a text document I actually removed that. So this bit here, this choose file, you can switch between different tile sets. They all have to be the exact same size and be a PNG at the moment. But each of the different rooms can have a different tile set. And as you can see this green portal here, if you enter it with E, you actually move on to the next world, which is about to get cleared when someone enters the room, which is a known bug. But yes, then I have a portal in that original spot, which leads back to the original room. And then this portal here leads to the next room. And I've set up 3 separate tile sets for the 3 separate rooms, which again, yeah, it cleared the moment that I did. But yeah, this is what I have so far. Any questions, comments, whatever?
How do you rotate your character?
Oh, J and L rotates the camera, and I and K looks up and down. You can't actually these are just billboards, so the character's always facing, almost like the old Wolfenstein or whatever, so you can't really see the direction that other people are facing, but yeah.
I have a comment, James.
Oh, yes.
I think this is very cool. And
Thank you.
I like very much that when the little touch that when you move on to the slightly elevated brick areas that that it moves up a little bit in the 3D world, like your camera moves up.
Oh yeah, there's like collisions as well. So like if someone wants to jump, oh, is anyone in who's this person that's in this room?
I don't know. I don't think it's me.
That's me. That's me.
Oh, if you want to like go onto this tile here and jump up here, we can show someone like on a, or I can just do this actually. So if you press space, it jumps as well. You can see the height change, but yeah, that's it. Oh, the other thing that I've done is I have this download room data button. You can do it on any of the rooms, and it'll give you an example of what my current data format looks like. Over network packages, I end up compressing it down using message pack, so it's a bit nicer. But yeah, this is like the data for one of the rooms. The plan is that you would then be able to go to another room and upload that room data, and that would kind of count as forking a room and like duplicating it, at least in the early stages. Or if you wanted to go to another server, you could re-upload it. Or if you wanted to go into another application like Blender or Unity, you could load your map data into these other applications without necessarily being connected via, a direct connection. Yeah, anyway, that's my demo. Thank you for checking it out.
Yeah, James, I think this is you can keep it open for I think it's it just feels to me like primed to get a lot of people excited.
Yeah,
it makes this very tangible where you're playing with the state, you can see it being fast, updated in real time. And then I love that then you have the JSON available. And it strikes me like there's some kind of it'd be cool to show off. It feels like it'd be cool to show off some of the other CRDT properties of this, or even the braid properties of this in this demo, like going offline and doing a bunch of stuff and then coming back online and having
well, the ability to go offline and do those changes and come back online is already working. But yeah, and I've also tried to add, like I think I showed in a previous session, I've got like collaborative text documents that can be projected onto walls. They're just using replace-based fields, but yeah, eventually I want to use something that's like proper list-based. But yeah, there's a ton of more composable CRDT types and things like that I'd like to build into it. I actually like I've been thinking about where I want to take it, and I'm really keen on making like a full-on light game engine, kind of like Pico 8, that is collaborative and synced by default, and you can just like create new entity types and add entity like components to it. So you could be like, I want to add a collider and gravity to this object, and I want it to have, you know, this kind of mass, and here's the texture or the model that's going to be used for it, etc. And then like, I don't know, webhooks and a whole bunch of random things like that. So you can like click a button in the world and it will call some code that's like on a server somewhere, or like another server would call some code in the game world, or I don't know.
Yeah,
Lots of
that's
random things
cool.
like that.
Yeah, and another thing in that space, like you showed being able to download the state as JSON. It could be cool to even just have it in a text field so I can copy and paste it. And I could like copy it and then go into another world and paste it in and have like a copy of this other world state or something.
Yeah.
You know, it feels like
Yeah.
having the state really accessible like that makes it feel like I can own it and I can manipulate it. Yeah. And it's in like a common format.
Yeah, I definitely like the idea of like I was gonna do the download button and then an upload button, but I think the idea of like being able to just copy and paste something as text is also like potentially making it more accessible. And then you could even like edit the text directly. Like you could press a button and it would open up a thing, and you could have the text of what the world's data is, and you could swap out like bits and pieces of it.
Yeah.
Instead
You could,
of
like walk around, see your coordinate update, and then edit the coordinate.
Yeah. We also had I haven't got it merged in, but there's a embedded Unity project that talks to Tiny Merge. So like you can actually use the Unity game engine and have it pulling in data from that collaborative world like in real time, and then things that happen in Unity could update the store for Tiny Merge as well. But yeah.
All right.
I just wanted having stuff copyable as JSON is very nice. I've experienced that elsewhere. I don't know, it just makes it. I've seen it in Factorio. It is a game. You can create buildings and such, and you can copy stuff from it. I'm pretty sure in JSON, and it just opens so many doors for people to start to play around with it in other weird ways online.
When I did Boilerplate, my little 2D editor, you could also copy and paste, and the copy, you can override the copy event handler in browsers. So you could just select things and copy them, and it would just put actual JSON on your clipboard, and you could just paste it back out or paste it a text file and things like that, and it worked great. So
yeah, I agree.
That's cool.
Yeah, little things. When you jump, it also scrolls the browser window, which it probably shouldn't do. And it'd be cool if like the keyboard shortcuts weren't so inscrutable if you want people to use it. I feel like it wants to be full screen or something rather than being like a little pane in a scrolling browser window. But yeah.
You mean James?
James's thing, yeah.
Oh, for that, I have a similar. For moving around, I think I already told James this, but I think the mouse might be nice instead of the I, K, J, and L.
Yeah. I think there's something interesting that like there's a bunch of, I didn't really show it in this demo, but there's a bunch of things like interacting with an element and then a modal popping up, and like I like the idea of mixing in HTML DOM elements with the canvas kind of like WebGL renderer, and so yeah, I think it probably needs to be something a bit more full screen, but also I want to be able to overlay other things and have other things on the page. So it's, yeah, I don't know. There's a lot of playing around to do.
On that last point specifically, I don't have anything to show right now, but I do have some code samples where I was exploring that for like a little bit of like, what would it look like to have like some world underneath where you're kind of like navigating, like it could be the web browser, like anywhere you go, but then like just having like hooks like on top of it, being able to pull out drawers like and like modals and stuff like that to simply be able to share that state.
Look, human being.
It seemed like somebody started to say something, but then it cut off.
Anyway, that's really cool. Should we move on?
Jay, are you ready to lead us through decentralized identity? We got so excited.
Yeah, I think so. I'm going to turn off my video, so hopefully it's faster on the screen share. So,
And guys, the slides are linked from our meetings page.
okay, so hopefully you can see that.
Yep.
Yes.
Let's see if I can. There we go. Good. Awesome. All right. So this is I'll try to keep this to like 10 minutes or so and just sort of do a run through overview. But I've been involved in identity and decentralized identity for a long time. I come from a telecom background, and the AT&Ts and the Verizons of the world have wrestled with, I think, some of the same problems that are coming up now around identity, identifiers, and so forth. So here's a little presentation that I put together to kind of highlight a few things. And I'm calling it viable decentralized identity. And the viable word is important because there's a whole bunch of initiatives out there to introduce decentralized identity. And, the question that I think is often missed, and I've seen groups put years and years of efforts into various standards and initiatives and so forth. And, lo and behold, it's really not viable. So I think that's an important thing to keep in mind as, we talk about this issue of decentralized identity. And I'll go through a few quick introduction or definitions, and then I assert that decentralized identity is elusive, and there are numerous entities and groups and so forth that are trying to get their arms around decentralized identity, and it seems to fail over and over. I think not the least of which is Mr. Musk, with his purchase of Twitter, seems to be running into some rather significant, what I would assert are decentralized identity issues. And this is just, keep in mind, this is just sort of a rough draft of an updated presentation. So some of this doesn't map exactly to the content that's in here, but I'm going to go over what I've been involved with that was tried in the past, which is called electronic number mapping, which was launched by the telecoms back in the late 90s and basically failed. And it's still alive behind the scenes in all of our mobile networks, but it never achieved what it was originally envisioned to do. And I assert the next point is, why does viable decentralized identity matter? I think it's, from my view, it's coming up over and over in multiple contexts, multiple dimensions, and it seems to be one of the key elements to usher in a usable decentralized web that actually works and delivers, what we're all hoping to see happen. I don't think I went into who's pursuing the decentralized identity, but suffice it to say that there's a bunch of people. So here's just kind of a laundry list of some of the dimensions that I think make this particularly elusive. Centralized identity versus decentralized identity. Again, to use Mr. Musk as an example, I think when he created PayPal, he was, very attuned to centralized identity and how that worked and so forth. But now with Twitter, which is not exactly decentralized identity, but it's certainly closer to decentralized identity, I think, that's starting to give him problems. And anyway, I could go on and on about that, but generally the next point, attestation versus contest, or attestation versus curative. The the approach that I see most of the initiatives taking is attestation, which basically means Michael asserts that Jay is who Jay is, and Jay asserts who Michael is, and somehow we tease out authenticated identity from that. And I assert that is similar to basically the title image, or the image on the title slide, which is the snake eating its tail, and self-referential, basically. And then skin in the game, no skin in the game, bounded versus unbounded. I'm not going to go through all these. A big piece is human friendly versus machine friendly, particularly with the W3C and the DID's recommendation that it was deemed a recommendation in July that they've been working on for about 5 years now, instead of a standard. I think they stepped over the human friendly side completely, and that's, again, makes the DID initiative via the W3C I question the viability of it. New versus in use is sort of adoption, scaling, etc. I assert, and again, this is from my telecom background, where I've seen different addressing schemes introduced, and the adoption just never got off the ground. Trust versus distrust, I could go into a bunch of these things, but I'll just kind of skip into the definitions and so forth. So let's start with viable. Here's a definition: capable of working successfully, feasible. And again, I think that the viability of many of the initiatives that I've seen worked over time in various contexts are basically just not capable of working successfully or feasible for a number of reasons. What do we mean by decentralized? Well, to move the control of an organization or government from, can't quite read my slide here, but to several smaller ones. And, certainly I think what you're working on Braid is a really cool approach to how do you move this control and this state management and so forth from a centralized control construct to a decentralized. And identity is the fact of being who or what a person or thing is, and that gets very tricky, much trickier than you would think on the surface. And then the second definition, I think, is subtle but profound, which is a close similarity or affinity. And I think that is often lost in the attempts to structure a viable decentralized identity. So here's my little project that I introduced in the context of DWebCamp. This is a really rough stab at basically pairing public keys with either telephone numbers or something that looks like telephone numbers. I won't go into any detail on that, but you can see in the middle of the screen, I'm using a toll-free number, the antiquated dinosaur that toll-free numbers are, 1-866-DWebCamp, as a easy to remember address, identifier, and so forth. And I think that's important. I think this is a realm that is overlooked. And I know some of you have been, some of you were on the HTMX session recently, which is a way to sort of take HTML and give it a simplified, more powerful functionality. And I think something similar might be available here using telephone number-like addresses. And I'll go into a little bit of that in a moment. So telephone numbers basically are dismissed as antiquated and blah, 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 but they've got some very interesting characteristics that I think can be leveraged in the decentralized identity realm. So here's a little video that actually Chad and Randy and I participated in HackFS in 2020, and we did a submission proposing a a directory of lookup numbers for HackFS, and this video goes into a little better explanation. But you can see again, here is something that's has at least a duality to it, if not a multiplicity, which is 1833 Hollywood, which is both simultaneously a number as well as a human-friendly phrase. And here you can see that teased out, where we have 1-833-465-5996, which is machine-friendly, but not human-friendly, and then the same identifier can be recast at the direction of the end user into 1833 Hollywood, which I assert is easy to remember. And I would expect that many of you the next time we meet could remember that particular identifier. So here is the failed electronic number mapping spec by the IETF, and that's been worked again since the late 90s. It is in use today, but it's not being used as it was originally envisioned, which was basically a way to create a harmonization among all of our disparate addresses, email addresses, phone numbers, physical addresses, social media. The idea was to have all these identifiers and locators work in some sort of harmony, and basically it collapsed under numerous dimensions. So this is a little item that I put together called the end user identity paradox. And this effectively I presented this at what I call the funeral for end user opt-in enum, and you can take a look at it. But this goes over, some of the dimensions that, at least in my view, I think could be a step towards having workable or viable decentralized identity. Here is the W3C did now recommendation as of July 19th, 2022. And I know that these folks kicked this off in basically 2017. So basically 5 years into it, they did a ton of work and hoping to get a specification, this classified as a specification, and it was sort of demoted to a recommendation. And in my view, this is horribly complex and, again, reduces the viability of this particular initiative. And it is almost completely void of human-friendly characteristics. Here's an example of a very simple example of a decentralized identifier. And, in my view, this is very much akin to the introduction of IPv6 versus IPv4. And, I consider IPv6 to be a questionably viable initiative to introduce a new set of identifiers and location addresses. So anyway, but that's this is a little bit about me. Here's sort of additional information. This is a presentation that I did at DWebCamp on identity, privacy, and decentralization. And then this is another presentation I did just prior to DWebCamp, referring to the DWebCamp directory that I was working on. And I could be wrong, but I think this approach is possibly a workable way to square Zuko's triangle. So let's see, that's about it. So I don't know if that's 10 minutes or, but I'll stop sharing, turn my video back on. And
I think we've got
yeah,
plenty of time.
uh,
I'd be curious to, I don't know what you guys think, but I'd be really curious to hear more of the detail. It sounds like you have a lot of background thought here in these other presentations. And if it wouldn't be too much of a pain for you, I'd love to hear some of the details on what you think went wrong with the existing approaches. And it sounds like that leads to some problems where you see yourself being able to square the triangle. And I'd love to hear a little bit about that possible solution too.
so the very, let's say, difficult issue of branding and you know, human-friendly names is generally shunned among the engineering initiatives that I've seen. And, you know, they don't want to sort out, you know, if Jay Carpenter, how many Jay Carpenters are out there, who's going to be the Jay Carpenter, get jcarpenter.com, blah, blah, blah. And I think that the missing piece in that is a market mechanism that allows, you know, jcarpenter.com to go to the highest and best user. So I think that's been one of the biggest missing pieces out of, you know, the mix. And so in North America, in telephone numbering, up until December of 2019, it has been illegal to buy or sell a telephone number. So I worked for 6 years with the AT&Ts and Verizons, advising the Federal Communications Commission on how to introduce a market mechanism for allocation of telephone numbering. That was immediately shelved until, I don't know, 2012, 20 whatever. Anyway, eventually it surfaced, and there was the first market for the 833 toll-free numbers. It was a disaster. Out of, I think, 8 million toll-free telephone numbers, there were 1,900 that were auctioned off. And that was an unfortunate situation. Australia had a open market for telephone numbers, but that also had some very unfortunate dimensions to it, where they wouldn't show the phrase. It would be like having a market for real estate where the only thing you could show was the parcel number. You couldn't know where the location was at. You didn't know if it was in Midtown Manhattan or out in the middle of the Sahara Desert.
So they're auctioning off numbers without telling you what the numbers were?
Yeah. Mm-hmm.
That
Wait,
seems.
do they tell you the numbers or just not tell you the human words that correspond to the numbers?
Right. They showed you the numeric.
Oh, okay.
You had no idea what that numeric might spell.
Yeah.
And the numerics, there's one numeric, and there could be a ton of different phrases associated with it. Yeah. For instance, 1-800-Napster also spells 1-800-MapQuest. Same numeric. What?
Just to name it with phone numbers. As an Australian, I don't think I think the last time I saw the phone number described with words was when I was about 6 years old. Right. That's not a thing that anyone does anymore here, but yeah.
The functionality of phone numbers, this is like a nuisance anymore, and people don't even do this. They do this now for the gesture. The problem is what people don't realize, and if you look at that RFC 6116, telephone numbering could be as functional or more functional than internet domains. However, it's been this lack of policy, lack of implementation, and so forth. And so anyway, yeah.
What happened with it seemed like when you were describing the downfall of the American auction, it seems like you said that there were only 18,000 or 19,000 auctioned off out of 1 million. I think I misunderstood. Were you saying that was the issue that they foolishly chose to auction off so few? Was the issue that there was no interest? That's all that they could auction out. They tried to auction off 1 million, but only 19,000 were sold.
They had potentially 8 million numbers in the 833. So if you take the specification for E.164 numbering, you got 10 million potential numbers, but because of the specification, you can only have 8 million. Out of the 8 million, they had like, I don't know, maybe, well, the bottom line is they only sold 1,900 numbers. So
but I guess did they try to sell more? Like would they, but people wouldn't buy them? Or
theoretically, they could have sold the entire 8 million numbers.
Like I don't understand if the problem was that there weren't enough buyers, or if they were only.
Did they sell, charge too much?
Like,
No.
Or was it just really inefficient market? No.
No, it was an incredibly cumbersome process. And again, there was no mention of the phrase, which is it was only the number. So
how much did they cost?
Well, the repeaters.
I feel like I would have bought 400 of these numbers if there is low amount of money.
Well, so the repeaters like 1, 833, 3, and then all threes would go for a couple 100,000. But I got 1, 833 Hollywood for nothing.
Are they still being auctioned off?
They're not being auctioned off. There's 1,900 numbers out of probably 100 million or more numbers in North America that are legal to buy or sell, and that went through the 833 number auction.
Are you saying that if at that time of the auction, that if more people knew about it and grabbed those numbers, that there could be at this moment floating around 1 million numbers that are buy and sellable, but they won't redo the auction?
Yes. Yeah, it was
This doesn't make any sense to me.
You have to understand that there's a whole different mindset in the telecom world around telephone numbering. So the metric is that there's about 300,000 or 400,000 phrases that are desirable, and that's been proved in various instances where 1-800 Walgreens, 1-800 Go FedEx, all that stuff. What I'm saying is the auction had no indication of what the numbers spelled. And the same thing happened in Australia. They shied away from publicizing the phrases, and I think it's because of their fear of trademark issues. But
I feel like I agree with Seth on I don't know that the names matter. I think they're cool. I actually do agree with you that numbers are cool. I think they're being used as identity right now. Like, as far as I know, Telegram on my phone, it seems to be tied to my phone number, not to my SIM card, not to anything but I think, I don't even know.
Yeah. WhatsApp, Twitter, I think Signal, Telegram, they're all telephone number centric.
And that makes it kind of sense. Like, it's not bad. But what I don't understand about this, like, if there were phone numbers sitting around, I feel like the issue is not that they didn't advertise mnemonics for these. I feel like the issue is like, I didn't know I could buy one, just knowing that I could, and why can't I now? Like
Is this a thing that we care about? Like, if we had a distributed naming system, does it matter how phone numbers work? Like, to me, that seems like technology from the 60s, not.
Yeah,
no,
yeah.
like I'm saying,
So let me.
Telegram, Signal. Are you saying Signal is designed stupidly, that it should do something different than?
No, I'm not saying that. I'm saying every time I go to the supermarket, they don't ask me for my email address. They ask me for my phone number. And the reason is, there's multiple reasons, but it's a fixed length for one thing. And that has huge advantages versus an email address, which has a, variable length. Here's where it would come into play in what you're working on. Imagine that there was a quadrillion numbers that were in sequential order that constituted a directory that where you could start to use those quadrillion. And the reason I say quadrillion is because the ITU specification for telephone numbering limits it to 15 positions. So you can go from 15 zeros to 15 nines. You've got this very nice sequence of numbering that you can start to create a directory that becomes your authoritative source of truth. And you can start to pair effectively an infinite number of like subdomains in that they're called NAPTers, naming address pointing records. But everything you're talking about with state, I think you could find this to be, I call it like a Christmas tree, where you can start to hang ornaments on this Christmas tree. And all of a sudden, you've got a new repository for state that the end users can control the state. And Jay can have a traffic light on a particular context that we're talking about that goes from, green to yellow to red, but I control it. And then all of you could look at that particular context, my traffic light on this authoritative source of truth, have confidence that it's Jay changing the signal on the traffic light, and you could start to key off of state that I'm in control of. Does that make sense?
Yeah, it seems like this sort of interesting spot on the, like, because a lot of technical systems are either human readable, fully human readable, like something like email, or they go down like, say with my Ethereum wallet address, so my public key, which isn't human readable, but it's got like these other properties. And if it's human readable, then you're looking for a centralized system, because you need to be able to assign the names. So we've got like the domain name system. And what I'm hearing is something like a centralized system that would let you assign numbers because there's only a quadrillion of them, but where it's still not fully human readable, like a Twitter handle. And I suppose I'm like there's something kind of old school cool about it, but and like, as you say, like the supermarket asks your phone number, not your like email address. But at the same time, it seems worse to me than a name. If you're going to have a central authority assign the names, why not just have a central authority assign strings? And then we're not limited to the number. They can be human readable, like, they can have other nice properties.
I assume, I could be wrong. I assume, Jay, I assume there's infrastructure for the phone numbers that you're taking advantage of. Like, I assume that if the phone numbers didn't exist, that you wouldn't be coming here saying, let's invent phone numbers. I assume that there's something that the phone numbers are already doing. And I'm kind of curious about that. Like, what is their infrastructure? Is it better than DNS?
I assert that it's better than DNS. And I assert that I would be coming to you saying, hey, there's a possibility of creating an authoritative source of truth that is decentralized, that could house state, could house a harmonization among addressing, and also trusted public keys. So I think, and I won't go into all the reasons, but DNS is exactly opposite the phone numbers. So With DNS, you have one, let's say IPv4 address, or excuse me, you have one phrase, let's say braid.org, and you can map any IPv4 or IPv6 address to that. It's exactly the opposite with telephone numbering. You have one number that is, 1-833-465-5996 that can spell Hollywood, it can spell other things, like the Napster, the MapQuest. The same number spells that, and it's up to the subscriber to that number as to how they present it. Do they present it as MapQuest or Napster? And the phrase, the human-friendly side, is intrinsic to the address because you've got one number and multiple possible phrases. So
yeah, I'm still confused why having the number that then we can have phrases that are associated with, why that would be better than just having the string phrase and have the string phrase be the mnemonic and what's used everywhere.
Because you have no anchor with the string phrase.
Isn't the string the anchor?
No, I'm saying that you focus on the numeric, the machine-friendly side of it as your anchor.
But
And
why not just make the string machine friendly?
you can't.
Why not?
Because there's all sorts of variability with the strings.
Are you talking about
So,
Unicode stuff like or Russian Cyrillic letters? Is that your concern?
well, there's also
Like,
different.
There exists ASCII in Unicode. I assume Seth is saying that strings can be mapped in the numeric system via that, and you are saying no. What's the?
No, there are different nuances, and the same word can mean something completely different in a different context. Not to mention, you still need the market mechanism in order to sort out who is the highest and best user of the phrases. So the phrase side is closer to the DNS side.
Yeah. I guess I'm not seeing the benefit of having numbers separately from the names.
I get it.
Like all technical things seem solvable. Like maybe there's something else I'm not seeing. Like the market side, great, but we could just put a market on the names. Like that would work fine. Like the benefit of a public key is that it's got some real technical benefits, right? But it's like really long. But then the phone number wouldn't have that. And if you say, oh, we could have a sort of some Christmas tree, as you say, of signers and so on, we could do that with strings as well. In fact, we do with DNS. Well, we don't really with DNS, but we should do something much better. But you could build something like that if you wanted to. So yeah, I'm happy to be convinced.
So if I get it, it's
I actually
go ahead.
I'm actually very excited about phone numbers, but I agree with Seth completely about the not because of the numerics or any of that. The only thing that excites me about phone numbers is that here's one property. I don't need a password for my phone number. Somehow, humanistically, I own that phone number. Nobody else can grab it from me. Somehow, it's not that they can hack it. I don't know how it's protected. It's not protected by my knowledge of a password. I might have a password for my phone, but there's no password for my phone number. My phone number is somehow, the government.
Badly, by the way. It's protected badly. Like SIM swapping attacks are increasingly a thing, particularly in the US, because it's very easy to buy a new SIM, convince the phone company that you're the same, that I'm Greg, that this is my new phone, my new SIM card, that I've lost my old SIM card. They'll transfer your phone number to my phone, and then I use that to reset your Gmail password and steal all your money. And this is an active thing that happens a lot. So,
that's the bad news and the good news, because okay, who can port your Gmail address?
Just us, right?
You can't.
Well,
you can't port your Gmail address.
Sure.
Can you port your phone number? Yes, you can.
No, wait, quote my Gmail address?
Pardon me?
Are you asking if I can quote my Gmail address?
No, port it.
Oh.
Can you move your Gmail address to Twitter or Facebook? No.
Fair enough.
You can port your number, your telephone number from AT&T, Verizon, blah, blah, blah. That is a big factor in pushing the control to the end user. So,
For what it's worth, I really agree with you. I had a conversation with the Blue Sky people where they were talking about exactly this property and how much they want that for the system that they're building. So the idea is that there's two levels. There's the idea of having an identity, which is associated with public key and whatnot. And then as a user, I can delegate and say, no, actually, I want my name to now be pointing at this different server over here, which is the authority on my behalf. And then you can use your same identity and move it between different providers. DNS obviously provides this as well, that I can register a domain name and then point it wherever I want. So I own josephg.com, for example, and I used to use Gmail and now I use Fastmail, and no one needs to know that when they email me. So I agree with you that that's definitely a desirable property. But yeah, I mean, we could obviously do that with strings as well, but yeah.
Yeah, and the indie web does that too. They have a system called IndieAuth, and their mantra is, as long as you own your own domain, that's decentralized enough for them, because you can always point your DNS records at anything you want. And so then you can port, but you have to own the DNS record.
Yeah, I think there's something that has to be owned in the same way that you kind of own a phone number, but don't own your Gmail address, but you do own your domain name. So I certainly hear that point.
well, that's just a little taste.
Cool.
Yeah.
And
Yeah.
What I would ask you to consider is, what would your CRDT and OT initiatives look like if you had an authoritative directory that could house state as well as disparate addresses that create some harmony to it?
Yeah, totally.
Yeah, for what it's worth, I don't have a problem with having a centralized authority for identity. I actually think that would probably work great. I think all of the good identity systems that we've ever made that work have a centralized identity, but then having centralized identity pointing at a distributed system, I think would work fantastically. That's my taste. I also really love, for what it's worth, I love the aesthetic of a phone number. Like, I really liked old school ICQ numbers, and like how they would get longer the later someone joined. That was great. And I'm now imagining if I ever made a fantasy console or something like that like wanted that kind of aesthetic. Like for something like James's metaverse thing, I'm imagining users having numbers based on the order in which they registered, and that being the primary identifier. That would be awesome.
Well, they can be incredibly valuable. So up until, I don't know when it was, the 90s, AT&T had 98% of the collect call market, which was worth billions back then, when billions were worth something. And then MCI came along and took a number, 1-800-COLLECT, and they captured 60% of the collect call market with that number because people could remember it. So capturing the dance of the human friendly and the machine friendly can be incredibly powerful. So that's, anyway, if nothing else, the group knows a little bit more about what my interests are. So
thanks. I really appreciated you presenting. Cool.
I'll just reflect. I appreciated learning about phone numbers and learning about the bureaucratic kind of like portability, or the bureaucratic things that happen there, and those failures, and also learning about the portability issue was very interesting to me too just now. Thanks for that, Jay.
Yeah.
Okay. Well, next up, so I guess next up is me. I have two things. So I'm going to reverse the order of them. Oh, I just did. Great. So let's talk first. I'm going to talk, go through some of the lessons learned from this, basically a trip report from this workshop I visited. So this is with some academics that I know who are trying to have, a lot of it's like having knowledge graphs of scientific arguments that scientists can participate in by adding a claim, questioning some data, et cetera, et cetera. But in this, it turns out there's a lot of synergy with DWeb people. And I ran across someone there who was just like, straight up like wanting to hack on ActivityPub. And he was like, I got a position, or I got like some academic funding, so that I have a way to be funded working on ActivityPub stuff. So I was in a group. The general idea of this was trying to use Mastodon or ActivityPub as a data sync backend for publishing new types of science information stuff. Like, so the observation is, hey, a lot of scientists are moving to Mastodon, and this is something that's open source and open protocol. Maybe we can hack this to use it so it's better for science. A bunch of people that are like, yeah, Twitter's been super useful for me for science, but now we can make it even better. So some of the ideas they had was faculty job openings are often published on Twitter. And if you could have a semantic item for that, then you could get this list of all the job openings that are coming up. When you publish a paper, you could have an item for that paper that's being published. And then when other people are referring to the paper later on, you could track all of their comments and critique. When you're reading a paper, it could push a little item out there into your Mastodon feed so that other people can see what you're paying attention to. And that's useful for people who are like, oh, I'm interested in that too. Let me see all the people who are reading that right now, and we can start a conversation about it. And then you could also have discussions on papers where you talk about specific claims, questions, data, or critiques, and you could kind of push those out, and they could all be related together. So you could have, like, then if I'm reading the paper, I can see the threaded discussions of all these things happening on that. And for those of you who don't know, so ActivityPub is very related. Let's just open up the, let's hope this is the right link. No, it's not. Well, it's okay. It almost is. So it's like, so ActivityPub, there's these streams, and it's basically a standard where you've got servers. There's a server to server protocol and then a client to server protocol. And you can imagine every user is putting out streams of tweets, and those streams go into, I wonder if I can, let's click on this one. That's fine. Okay, and so you've got these streams of tweets, and messages are going out into from people's outboxes into their inboxes, and the messages are these JSON LD objects. And a nice thing about JSON LD objects is that they have a schema attached to them and an ID, and you can come up with additional schemas to create new types of objects. And there are a whole bunch of objects created for things like, this is a like, this is a create of a post, and it's creating this object that is a note. And so you can imagine extending this with other types of data. So this was the basic idea of the group. They were trying to create new types of objects and send them out over ActivityPub. And so the way that this relates to us is that ActivityPub is a peer-to-peer, it's like a peer-to-peer Twitter. And Braid is more of a peer-to-peer state synchronization. And where you could express Twitter as a schema within state synchronization. And so from that and watching them work on this, I mean, I was part of it too. These are the challenges that we ran into. And so these are things that just in our practice come up as things that we might be interested in solving. So first one was, it actually was not that hard to add new data types into the system and distribute them. But it was hard to add new UIs. So like, if you've got some new data for like a research paper that's going around, you might want to have a special UI for it, both to post this kind of new data without like pasting in the JSON LD, and also to read it. And the problem is that there are a few different Mastodon instances, and all of them have different UI models and different ways of rendering UIs. And so you kind of have to go and like hack all of these different instances to add a new feature. And this brings up a problem of, wouldn't it be nice if you could mix and match UIs and more flexibly include them? And this is related to a couple of things. I was talking to Tyler about it because, I mean, honestly, this is what I think the drafts, I think Tyler just presented this last week. Yeah, here it is. Great. I knew the URL. A user interface module spec. So you could have a standard way of adding in new UIs and have them mix and match. So this problem just came up at this workshop. So I want to reference that. And Tyler also mentioned that he was talking to Mark Nadal this weekend, who had a proposal for how to address that. And this is the website for it, which doesn't say much, but it links to this article in Hacker Noon where he says a bit more. And down here, I think in the summary, where is it? somewhere in here, it's like, imagine having a mixture of an app could be a mixture of subcomponents from different sources, which in turn might securely request rendered data from different places. So there's this kind of general vision that we haven't been talking about very much, but it's coming up in practice when people are building stuff. And so,
If I can,
yeah,
jump in there one thing. So I'm gonna meet with Mark again tomorrow and a few other people like on the secure render stuff. So I'll get like more context on that. But also from a quick demo that Mark gave me yesterday, it almost reminded me of, so James is like projecting onto the canvas, like for like being able to project onto that wall and like being able to like render stuff like in there, like externally. I think that also has like some interplay. So I'll keep tabs out for that.
awesome. Yeah, that's a really good shout out to James's thing too. Yeah, good point. Yeah, great. And you guys are meeting in the Bay Area somewhere?
Yeah, we're gonna be in the mission tomorrow. So if you wanted to
Okay.
go.
Yeah, maybe I can. I'll be in touch. Okay, cool. This is also related to Figma's secure plugin system. So one of the key issues here is if you're including UI code from different sources, you want to make sure that the UI code is sandboxed. And Figma's done a lot of research on how to do that. Some of it using WebAssembly sources. You can also use iframes. You want that to be efficient. And anyway, so Mark's working on that too. So that's one issue. Another issue was so ActivityPub is a way to stream updates around the network, but you often want to just like query some data, and without having to build your own instance where all the data is coming through and storing it in your own database. And you also might want to access other data without, like, all that other data is going to be streaming through in some other database format, or it's going to be mapped into some other database format. And you got to take all that data, then aggregate it. And you basically got to like repeatedly write a lot of code for other things. And so this is something that I think Braid, so I guess one example of this, one of the issues is that you have data in various formats. So some of the data they were streaming across the network were these RDF triples. And those like things like RDF is semantic web stuff. And so it contains claims like you'd say, Greg is a programmer and James is good at speed runs, or Seth wrote a cool blog post or wrote this blog post, or is an author or something. And those triples are useful for like, if you want to get let's say you want to like, it's one way to, it's a way that some of these systems are storing data for scientific discourse. But in order to use that data, you have to do these queries over an RDF database using this syntax called Sparkle, and you need a Sparkle query parser and all this stuff. And so if you just want to like access that data, now you can implement that all on your own, or use some other system or something, but there's this giant hairball of system you have to take with you. And this is something that we can address well using Braid or the web by having like a running system that you could query with a URL. And you have like state that can get repurposed, and you don't have to build everything, but you can access the state from that database in a standard format. So having a standard for accessing state and not just sending updates would make it a lot easier for us to build these decentralized systems. So we just saw like, they're like, okay, this came up in the programs. They're like, hard part, we've got all these different formats. We have to write this complicated parsing code because the data is in different formats. So some of the data was contained in HTML with micro formats, from the indie web people. So then you had to get an HTML parser, beautiful soup, get this tree back, access the tags in the HTML, and then get into the micro formats, which are like, I think, classes or something, to say, okay, this is an H card. And then you can crawl over and now get the username. And some of it's in JSON, and you're just kind of like doing all this different stuff to integrate stuff together. And if we can have, just a more if we can make it easier to have, like, first of all, we could have a bunch of JSON, but also we can have representations of data and state and be able to access them and have those things be live, updating synchronously, so you can just kind of access servers or accessing other servers or peers or whatever they are. Okay, that's the end of my trip report. Any questions? Otherwise, we can just move. Okay.
Very cool, Michael.
Thanks for listening. Okay, so here's what I'm mostly working on. I'm gonna click this. I think it's just right over here. Wait, right here. Okay, great. So I'm working on a paper that is this is what I've been presenting on last couple of meetings. This is a new type of both OT and CRDT in a sense. So there's a new and which we've been programming with. It has some benefits, and it kind of changes our minds by seeing that these two things are more the same than we thought. And so anyway, working on the paper for this, and but the main thing that we've got some progress on, I've been working with Raf to get a proof. And so I want to take you guys through some of that proof here today. So this is a proof that time travel, okay, so this is like a name for this thing, is a new type of CRDT and a new type of OT. So here we go. So this is the CRDT paper from Shapiro. This is like what defines CRDTs. And CRDTs have these two types. You've got a state-based type and an operation-based type. And these have slightly different mathematical formulations. So this one is the object-based. It says, as long as you define an object with these methods, and you have certain properties of these methods, then you can guarantee that you're going to get strong eventual consistency, and everything is going to be the same. And that's the advantage of the CRDT approach, is you can express your data structure in this format for operations, or this format for state-based, and you can guarantee that it'll converge just by making sure that the methods obey certain subproperties. So, so this paper is to say, hey, there's a third type. Well, there's actually a third type already called delta state, which is a subtype of the state. But this is a third top-level type. We need a name for it, so I'm calling it time travel. And we want to say that this is a type of CRDT, that has some property. If you have some methods, if you give some properties to the methods, then you can guarantee that it'll converge. And in this Shapiro paper, he shows that the state-based and the operation-based are equivalent. And so I want to show that this new type of CRDT is in the same equivalence class. And the way that he shows this is he says, we can take an operation CRDT and make it emulate a state-based CRDT. So in other words, if you have an operation CRDT and you know that that's working, then you can implement a state-based one on top of that. And vice versa, if you have a state-based one, then you can emulate an operation-based one. So we've got here we've got a formulation of a time travel CRDT with these 6 methods or fields. And then we prove that a time travel CRDT can emulate an OP-based CRDT, and vice versa, that an OP-based CRDT can emulate a time travel one. So I just kind of want to take you guys through the rough shape of this proof to get, and it's not complete yet, but I want to give some intuition here for what we're looking at. So here's a high level on what time travel means. So and the key difference with an operation CRDT is that an operation CRDT takes all of the edits. Every time you edit the CRDT, it converts the edit into an internal format and sends that internal format over the network. And with a time travel CRDT, and that internal format depends on the algorithm that you're using. It's defined in the CRDT. With a time travel format, we have one common format for editing the state, and you don't convert it to any internal format. You just send that directly over the network. And then the time machine takes that edit and converts it into a format that can be applied at the receiving peer. So you have the, so each peer just, it has some state that just edits linearly. The receiving peer has state that it has its own timeline of edits. The sending peer has its own timeline of edits. And instead of having some, and then these timelines might be different. And so we're going to do operational transform to convert from here to here. But we're going to do a generalized type of operational transform that we're calling time travel that can move from any point in time to any other point in time. Okay, and there's this time machine is the object in the middle that builds up some state from all the incoming edits. So here's all the edits in this DAG. It builds up some internal state, and then it uses that to do the transform and move edits across. So let's go through the proof a little bit. I'm also finding that maybe I'm running out of articulateness, and if I'm losing people also, we could just push this off and I can do it clear at another meeting. So I don't know, should I, how is this coming across to you guys? Maybe we'll just ask, let's get a little interactivity before I just drone.
I'm still here.
Okay.
Yeah, I'm still here as well, but I'm like, my Zoom fatigue is kicking in and I'm fading a little bit.
Yeah, I'm feeling that. Okay, then I'm just gonna do like a little hand wavy conversation that only requires like 50% brain power. Okay, so so this is the time machine is an object that has some internal state of the time machine. And then it contains the current snapshot of state. So your peer is going to have two pieces of state. One is a current snapshot, just the data however it is. And then one is this time machine that you can you can do that in different ways. You can build up data or not, but that's what you're going to convert operations with. And it's going to have a time travel function that can move operations across so that it applies to your current snapshot. So we're going to convert this. We're going to emulate an operation-based CRDT with this. And the main difference with the operation-based CRDT is that the operation CRDT has this thing called a prepare update. And so whenever you edit it, it's going to turn that into an internal format. And so with our time travel CRDT, we are just going to do a no-op. And we're going to say that the internal format is the same as the external edit. And so that edit's then going to go across the network. And then when you receive it, you're going to do some fancy stuff. So we're going to update the time machine with the new edit, and we're going to update our current version of our snapshot, and then we're going to time travel the edit and apply that to the current snapshot. And so this is a formulation to do it. What we haven't totally finished here is the proof to show that it converges to a CRDT, because we have to define the properties of the time travel function. So that's like to do. That's the outstanding work. That's what we're working on right now, is like, how do we define the time travel function and its properties? And that's actually, it feels very interesting because proving that feels like it's somewhere in between proving that operational transform works and proving that a CRDT works. And it feels like there's some new mathematical understanding here that might connect the two together. So I'm kind of excited about that.
In defining the time travel function, you expect to see this connection?
Yeah, so we're not going to, the time travel function, you can do this in different ways. And so we're not saying like, here's the algorithm for time travel, but we're saying when you write a time travel function, these are the properties to think about. So this is a way to think about time travel, where as long as you satisfy these properties, you can guarantee that the whole thing's going to work. And that's kind of the brilliance of the CRDT thing. Is like, as long as you satisfy these little properties, the whole thing will work. So it simplifies your problem.
I see. So in kind of understanding what the necessary mathematical properties that guarantee that you have a so-called time travel function, in understanding those, you expect to see this connection.
Yes, yes. And it's going to be both the time travel function and the time machine. And that's going to help us understand what that thing really is. Right now, it's just like, we have some intuition that it's interesting.
Right.
We're trying to formalize it.
Cool.
Yeah. So here's going the other direction. Let's say that we have an operation CRDT. Can we create time travel with it? And so here's what we're going to do. Now I'm confused. Oh, okay. Yeah. So, okay. So we are going to, so the intuition is that so this is going to be, this is not going to prove it in general, but it's going to assume a couple things about our operation CRDT. It's going to assume that we can compute a diff across two reads of it. So if your data is a string or it's JSON, you can compute a diff. But there might be data formats you can't diff. And then it's going to prove, and then you also assume that you can express that diff as an operation in the CRDT. So it's going to assume that the operations of the CRDT let you to convert a diff into an operation. Because the one thing that we want to do here, an operation CRDT just has a read function, but a time travel CRDT has to produce an operation that you can edit your state with. And so the basic idea of what we're going to do is create an operation CRDT, and we're going to have it read off the version before a new edit comes in, and read off the version after the edit comes in. We'll diff those two states, and that diff becomes an operation that we can use to update a snapshot. Okay, that's all I'm going to say on that.
Just curious, how did they, in the paper, when they prove originally that you can create a state-based CRDT from an operation-based CRDT, do they have to do a similar thing there to to create pseudo operations?
No, because both a state-based CRDT and an operation-based CRDT have get the output from a read function. It doesn't update a snapshot with a diff.
I see.
The difference between state and operation is what it's sending over the network.
Interesting.
And that is the one quality of operational transform that not all CRDTs meet. Like not all CRDTs, the definition of a CRDT does not say that you can compute a little diff to update a snapshot. It just gives you a read function.
I see.
Yeah. Okay, now I'm just tired. Anyway, so we're kind of pinning, the current status is we're pinning this stuff down, defining the time travel property and the time machine property, which is maybe like one of the deepest parts in this model, is to understand what you need for that time machine. And then we're going to pop up and prove the TP1 and TP2 properties, which we feel like we could do, but we're not sure exactly what we're linking to that proof. So it seems kind of like that should be straightforward, I think, once we've pinned down the time machine properties. Thanks.
Great.
I really like that you're going through with rigor to actually like prove some of these things that have been done kind of in a more practical way. I think having that proof is really valuable.
Yeah, I'm learning that mindset too, because I've just been proving things empirically with fuzz tests. I think Seth's been doing that too, and that feels like the only way you can make these systems work. But there's this, like, all of this operational transform stuff started off with mathematical proofs, and they're only like, I think 20 years, 15 or 20 years into it, did people start regularly doing fuzz testing. Like the first well-known fuzz testers I know were Cephs with Share.js. There probably were some before that, but
yeah, there's things like fuzzy lop, which is like binary fuzzing, but property-based testing has been around for a while, but it's always been a different thing. But yeah, and also to name it, some of the early operational transform algorithms actually weren't correct once people plugged fuzz testers into them. So it turns out you can mathematically prove something while it's still incorrect. And it took least for them to discover that.
I just had the same thought as you. It seemed like they did quote unquote prove some things about operational transform that turned out to be
Yeah.
invalidated by fuzz testers.
Yeah.
So like in a sense, I hold them both in high regard, but I'm not sure that I would really say that proofs are better than fuzz testers, because there's a kind of error that they can have, a human error of not realizing that you haven't really proven it.
Yeah, well, I think using something like Ada or like, Idris or one of the computational proofing systems is probably the best. But yeah, I think that they're both valuable, but I agree with James that actually connecting what we've been doing with the research so that we can talk about it in the academic context and give it that kind of grounding is really valuable. And I know that's something that I've avoided doing because I hate reading papers. But it's great.
Straight up. Yeah, I'm noticing this, the same thing. The value that I'm noticing specifically is that I have a better, by going through the steps of trying to prove it, I have to understand it better. And I'm finding that I have all these intuitions about how the system works, which were, I believe the intuition strong enough to build a bunch of visualizations and define some specs, and write code. But there are still holes in my understanding of what to name all the intuitions, which things distinct, how do they all connect together exactly? And my mind would just kind of skip over it and hand wave whenever I had to think about it. And now having to pin all that stuff down, I'm like, oh, actually, this is interesting. And I'm happy to learn this additional stuff. And so, yeah. Anyway. And I'm also recognizing my math bias. I think that school mathematics teaches us that there's a lot of BS. And I found myself like ignoring, my eyes would glaze over whenever I saw Greek symbols. So I'm unlearning that now. And it's like, oh, there's all sorts of enlightening things in here.
Yeah, that's cool.
Okay.
Yeah, I'm still not sure why all the method names have to be like 2 arbitrary letters though. I wish they just use words.
I feel the same way. I'm kind of feeling the benefit. I'll be able to get back to you on that later.
Fair enough.
I think it makes sense when you're doing it, like when you're in it, when you're proving it, and you've got all this crazy stuff, and like at some point, like you're reducing that name for yourself to be able to talk about it easily because you're writing it again and again as you're trying to get this proof together. And I think that when you get to the end, 2 things happen. One is like you want to keep it in that delicate form to kind of prove that you're a cool person. You got the cred to be able to write like Greek symbols. And the other is that you kind of think in that moment that this is so clear. You've condensed it. You've spent all this time distilling the essence, and here it is. Other people won't have to go through that. But it is somehow not true. Somehow, for me, I can't understand the distilled essence without reconstructing it somehow.
I've got, this is a slightly tangential question. So I looked up semi-lattices the other day because apparently the time DAG is just a semi-lattice. Why are they semi-lattices and not lattices? Does anyone?
I don't know the difference between a semi-lattice and a lattice. If
Well,
someone can tell me the difference, then I could tell you which is why.
Semi-lattices are either meet semi-lattices or join semi-lattices, in that you can either like always join things together, which I think is what's implied, but you can't necessarily, you can't necessarily form a parent version from any 2 parent versions. Actually, I think I've just answered my question. It makes sense that you could merge any 2 versions. So that's the meet operation, but you can't given any 2 versions, you can create a new version that's where they join, but you can't create a new version where the specific 2 versions came from. Yeah. It's something like that.
I see. Interesting.
I thought it might have had something to do with the partial or with the directedness.
No, lattices are also directed graphs, like DAGs, and anti-symmetric DAGs. Sorry, anti-symmetric. Yeah, they're DAGs. I spent some time with Wikipedia the other day. So
I know there's this space of things, and I have to look up some of these terms when I am trying to get into the particulars of them.
Yeah, I've been trying to figure out whether it's worth using more mathematical terms in my code. So for example, there's the idea of a supremum. So if you take the you take the semi-lattice, you take the time DAG, then the supremum is given any two versions or any like set of versions. What's the minimal version set such that like the kind of like least common multiple or something like that of the versions that you specify, which turns out is to be something like very useful. And there's also like the kind of greatest common multiplier type idea of given some set of versions, what's the given some set of versions, like can I remove some of them and still have it express the same version, like if it's a frontier, and there's a few different operations, but yeah, there's like a supremum and an inferium which are defined mathematically to map to some of the functions that I already have in diamond types to do these kind of operations.
It's interesting. I have the same sort of things in Sync 9, but like I have a thing called leaves. And I think that is, there's probably a technical term, maybe the thing that you're mentioning is supremum or a.
Are the leaves the things that have no children, like have nothing that depends on them directly?
Correct.
Okay, because I've been calling those the frontier of the graph.
I've called it the frontier as well, but
yeah, but there's a question of, given some set of versions, what's the smallest frontier or like the smallest set of leaves that distinctly contains those versions? And that's the supremum of a set of versions, and so on. Like you can go through all of the, like you can map the terminology across. But anyway, I'm just like, I think it's useful, but to mathematicians.
Yeah. I think it's when you want to get to the level of precision that you can prove every little term together. It might be useful using the mathematical definition. And because you're like, oh, now you know that I'm precisely referring to this mathematical concept, which has all these entailments. But if the purpose of the code is to convey an intuition to a random programmer, then you might want to use the lay definition.
Yeah.
This provides enough intuition to let him try to hack it and run the tests again and see if it passes.
Just to very briefly screen share, this is something I really liked on the Wikipedia page. There's this like show transitive binary relationships. So this is a semi-lattice. So obviously there's like meet and join semi-lattices, which are the ones that either will let you merge any two operations or you can have parents of any two operations. But lattices can do both. And they're all anti-symmetric because if A depends on B, then B can't depend on A. It's not just that it doesn't necessarily, it's that the inverse relationship can't be true. But they are reflexive. So like, anyway, like this sort of thing is beautiful. And I like it.
That's wild. Yeah.
It's like the math people have their own API for like a special name for all the things. And I agree, it can be fun and cute to name things in the way that, you know, to have some cooperation there.
Yeah, well, I feel like
I want to memorize that table.
Yeah, but we've talked a lot about time DAGs, and it's like the mathematicians have a name for that, which is a join semi-lattice, and and other people in other fields talk about like causal graphs, which is the same idea. But anyway, I think it's useful to know.
Yeah.
So
I could say more. I feel like I want to just shut my mouth. I feel like it's been 2 hours and maybe
we should stop the recording and then we can